Hello, everyone, and thank you for joining today's SenzaFili Sparring Partners webinar on Terragraph. 60 gigahertz fixed wireless access gets real. Our speakers today are Gino Villarini, founder and president at Aeronet, Derek Peterson, CTO at Boingo Wireless, Mark Kelly, strategic partner manager at Facebook, and Monica Paolini, principal at SenzaFili. I'm Kendra Chamberlain, and I'll be moderating the debate. In Sparring Partners webinars, we watch debaters discuss a topic and answer questions on video without slides. We would like to encourage our audience to participate in the conversation. So please share your questions and comments through the Q&A tab at the bottom of the Zoom screen. Please keep the conversation polite and respectful. We will do our best to address the questions as our speakers go along and as they become relevant to the topics being discussed. We're also live tweeting our webinar today, so you can join the conversation on Twitter using the hashtag #SparringPartners. We're also noticing a little bit of video quality disruption on the Zoom platform, probably because lots of people are working from home. So please forgive any pauses or stutters in the video. All right, our sponsor today is Facebook, and we'd like to remind everyone that our debaters are presenting their own views and not those of the sponsor. Okay, and with that, I'll hand it over to Monica.
Oh, I was on mute, sorry. Kendra, thanks for the introduction, and thanks for the panelists and for all of you to call in such crazy times. And it is really a pleasure to talk about 60 gigahertz. And Kendra, could you start with the first poll? We're going to start with the poll first so that we get your views on this.
Okay, first poll. What is Terragraph for? A, fixed wireless access. B, mobile backhaul for small cells. C, mobile wireless access. D, indoor wireless access. Or E, I am on this webinar to find out what it is.
Okay, I don't see the poll.
Oh, shall I try to launch it again?
Yeah.
Let's see.
You guys see it?
I do not.
Okay. Well, as Kendra figures out the poll, I guess it's things are not necessarily working properly today. But it's a great pleasure because 60 gigahertz is a great band. I think I've been for many years thinking that there has to be a good way to use it. And today we will talk about one way to, well, actually multiple ways to use it with Terragraph. So what we're going to do is to get some introductions. So we have all new speakers today, and here is the Terragraph first poll. So just please go ahead and answer the poll. And as we do that, let's get with the introductions. And Gino, do you want to go first?
Yeah, sure. Thank you, Monica. My name is Gino Villarini. I'm the founder and CEO of Aeronet Wireless Broadband. We're what we call a hybrid ISP. We started as a wireless ISP 19 years ago, but we along the way transitioned to integrate fiber and other technologies, mostly fiber and fixed wireless. But we still are, I would say, 85% fixed wireless. We provide services in Puerto Rico, USVI, and our main market focus is business, the business segment. In terms of 60 gigahertz, we started to do some trials with some equipment about a couple of years ago, right after Hurricane Maria. And now we're trialing a Terragraph network here in Old San Juan. Thank you.
Perfect. Derek, you want to go next?
Good morning and good afternoon, good evening, everyone. Hopefully everybody's staying safe and well. Happy to be here. I'm the CTO for Boingo Wireless. For those of you who don't know about Boingo Wireless, we are probably the first and one of the premier neutral host providers. So what we do is we provide networks for airports, is where a lot of people know us for. They started off on Wi-Fi, but we were doing DAS all along as well. And now we do airports military bases, multifamily dwelling units, as well as doing all the connections for the carriers through DAS and small cells and 5G networks. One of the areas where we use a lot of point-to-point radios is in our military footprint. We have over 2,600 point-to-point radios in that footprint as an alternative to being able to use fiber, which we'll talk about later. Happy to be here, and let's get going.
Excellent, Gino and Derek. Before we go to Mark, why don't we see what the results of the first poll so that Mark can introduce himself and Terragraph as well.
Okay, our results are in. Fixed wireless access received 62% of the vote. I'm here to learn received 18%. Mobile backhaul for small cells received 13%. Indoor wireless access 5%, and mobile wireless access received 2%.
Perfect. Mark, your turn.
Sure, thanks. Good morning, afternoon, welcome. Sorry, Monica, go ahead.
You can comment on the poll results. Is that
Yeah, let me just comment on that right away. Just, I had to laugh when I looked at it because it's kind of a bit of a trick question because Terragraph can be used for fixed wireless access. That's what we're going to talk about the majority of the time this morning. Can also be used for small cell backhaul, and that's been demonstrated already, and that's a where we're moving into this next year. And then it's conceivable you could use it indoors, but there's already a lot of good indoor technology in the market today. And in fact, if you look at the really the root of what we're doing with outdoor use of 60 gigahertz, a lot of it's anchored going back to AD, the original 60 gig spectrum, which has got all the same elements with a couple exceptions we'll talk about today for indoor use. And really, that's what we're looking forward to talking about Terragraph, this market, fixed wireless in general today. My role at Facebook is a strategic partner manager. So I work with people like Gino and Derek and others to really introduce some technology that we've helped contribute to at Facebook, as well as many others in the industry, that could help lower costs, speed up things, increase performance on networks in the US and globally.
Absolutely. So Mark, the very first question from the audience is about using it for long distance backhaul. So we talk about small cell. What about long distance? Can you use it for that too?
Sure. Well, you've talked about 60 gigahertz, Monica, before, and I think most people are familiar with the fact that 60 gig has a sort of a natural oxygen absorption boundary, which prevents easy use the way you see in other bands, and tends to attenuate the signal almost as strongly, about as the same as heavy rainstorm. So could you use it for long distance? You could use it up. It's conceivable, and you'll see some of our OEM partners and others have products that can be used several kilometers. So the issue with any type of a wireless system, a point-to-point system, would be reliability. And so we're talking about trying to achieve, obviously, the same level of carrier-grade reliability, particularly with small cell backhaul, but fixed wireless as well. And so to achieve that level of reliability, your link budget has to take into account all those different factors, including oxygen absorption and impairments due to weather and so forth. So that generally tends to limit the range to a few hundred meters. But as I said, it's conceivable. You could use a different type of system, and we'll get into some of the details of Terragraph, using a larger parabolic dish, which others have looked at, and you can expand the range.
Absolutely. And so let's go back sort of to the basics. 60 gigahertz. 60 gigahertz, well, obviously has been around for like every the other spectrum bands forever, but there has been through the years attempts to use it, but it never really took off. And it's kind of disappointing because there's so much spectrum. It's unlicensed in many countries, so it's really excellent. An excellent band, an excellent opportunity. So maybe we can start with Derek and Gino. If you can comment on why now? Why all of a sudden are you interested in 60 gigahertz? And we're talking mostly, again, today we're going to talk mostly on outdoor fixed wireless. But can you say why now? What changed?
Well, for us, 60 gigs represents a opportunity to provide higher speed bandwidth to our end users. The bands that are mostly available to wireless ISP operations are unlicensed 5 gig and 2.4 gig, and those bands are limited in capacity in terms of the amount of spectrum that's available on them, and also a lot of interference. So 60 gigs provide very huge channels and very low interference possibilities within the area. So for us, it was a matter of being able to provide high speed, reaching gigabit speeds to our end users at the low cost because of the advancements.
Yeah.
Yeah.
Manufacturers to come out with equipment.
I saw you pause there, Gino, and that's why we need it right there. You know, I'm using a point-to-point radio right now out in Utah at my ranch, and I would love to have the 60 gigahertz. I was told my video is not as great. I think, you know, one of the key things Gino shared was spectrum is important. We've all want more. We're finding unique ways to be able to get spectrum, you know, through different models that are coming out. You know, we've always had the licensed model, and then we had the unlicensed model. Now we have shared license model. But the key thing is when the government made this huge swath of 60 gigahertz available and it's contiguous, that really opens up a lot of opportunity to be able to take advantage of this spectrum to, as Gino said, to be able to provide that great connectivity that we all want in the rural areas and throughout the nation. And the big thing that we always have to recognize is there's a cost to deploying these networks, whether no matter what kind of network you deploy, whether it's a Wi-Fi or a cellular or an unlicensed or licensed, there's a cost factor that you always have to weigh in. And by being able to make more spectrum available, and we got to applaud, you know, the FCC for doing this lately, they're providing more and more of this unlicensed spectrum that we can all take advantage of for this case. And 60 gigahertz is one of those spectrums, and it's a great opportunity for all of us.
Yeah, absolutely. And it turns out that, you know, the traditional problem with 60 gigahertz, and still today, whenever you talk to people, so, you know, you can use 60 gigahertz, how about this? They say, oh, you know, the reach is not, there's not long enough reach. But it's actually an advantage in many ways because that reduces interference and promotes frequency reuse. So sometimes things that are an initial disadvantage turn out to be an advantage if you can leverage that. And actually, we got a question that is somewhat related, which is the coexistence with 802.11ad and or WiGig. And that's also an interesting issue because that brings up the issue of the market size and availability of chipsets. Mark, you want to comment on that? So is it?
Yeah, that's a great question. And that's sort of the obvious question because if you look at the ecosystem, which we've been trying hard to help develop and have had a good amount of success doing so, really based off of a relatively thrifty chipset. There's another question, who's that coming from? Qualcomm is supplier of the both an AD and AY chipsets, so we're thrilled about that. And Qualcomm, Facebook, a number of other large companies have all been involved, and small companies as well, in contributing to the 802.11ay standard. And within that standard, a significant amount of simulations and practical tests were done just on this coexistence issue. And in fact, the classic case would be someone using Terragraph for the transport in their network, going to a home, apartment, and so forth, where someone was using AD on the inside and how that works. And so a significant level of simulation and testing was done to ensure coexistence there. So we're confident that's at this stage a problem that's been solved.
Yeah, absolutely. And there is enough spectrum that you can easily share. So sharing it's easier when there is a lot of spectrum available.
That's absolutely true. And just to echo the point Derek made and what we're talking about this morning, with respect to 60 gigahertz, it was sort of a joke that it was the band nobody wanted because it does have, it's maybe not as ideal. It's not the long range band. You can get a common carrier bands. But if you look at common carrier microwave today, a lot of it's congested in most area. And in fact, even recently, we've been talking to service providers who remarked that in certain dense areas in metropolitan areas that there's an E-band congestion issue even. And so, you know, having another band that's 14 gigahertz wide, which is rather unprecedented in a lot of markets, it allows you that kind of flexibility. So making use of this band is something that's really incumbent upon the industry to do, and that's why we jumped in and tried to help out.
Yeah, and another point is that the band is multi-point capable, and licensed. You can use it for multi-point, whereas you know, V band and 80 gigahertz and other bands are just point-to-point.
And that does a great job in helping deal with some of the challenges you'll run into, where, you know, you might lose a connection because of those multiple points of connection. You end up providing better stability. So again, we're getting better at technology, and as we get better, point to point, some of these other technologies, our ability to be able to put packets together that may be dropped out of sequence in a lot faster manner, all those things are leading towards a better opportunity for us to take advantage of, you know, something that in the past we probably wouldn't have taken advantage of.
Yeah, so I would like to get to talk to you, Derek and Gino, to talk about what it is that you guys are doing on the ground. But before we do that, could we just give a quick update in terms of the standardization? Where are we in terms of getting to market? And I see there's another question about using 5G NR for the 60 gigahertz. And I guess within Terragraph, because obviously everybody can use whatever interface they want. But so Mark, can we do that, and then we can talk about exactly, you know, what specifically Derek and Gino are doing in their networks.
Sure. So from a standardization standpoint, as you know, this will all be wrapped up this year. You'll have the AY standard in the Qualcomm chipset this year. You will have OEM gear available from a multitude of vendors. There's at least 5 that we have announced that are partners with Facebook on this. And those radios will be available beginning in the second quarter, late second quarter this year. I think you'll see by the end of 2020, real healthy ecosystem with close to half a dozen OEMs using the Qualcomm chipset with different SKUs, looking at not just fixed wireless. I know we haven't spent much time on that specifically, but focusing on that for the second half and into next year when you'll see sets of larger deployments globally.
So what about 5G NR?
Yeah, so as I mentioned up front, we're really leveraging the development of IEEE 802.11ad. Essentially what was done, the big difference between AD and AY is the MAC. And so it's a TDD, TDMA MAC and not a CSMA MAC. And so by leveraging the existing standard and leveraging the existing work that's been done, we're able to bring this really low cost solution. As far as using 5G NR in the 60 gigahertz band, I think there's been some discussion about doing that perhaps in release 17. I think even for access potentially. It's this, what we have is a technology and a waveform perfectly matched to the channel and the technology development that's going on with AD. So it made the most sense to go in that direction.
Absolutely.
I would argue, I'm sorry, I was going to just say, I think it's a timing thing. I think, you know, the IEEE standard is available and we've been working on it for a while. You know, we started off with the AD and now we transferred to AY and added some, you know, capabilities, and there's been a lot of work there. The 5G NRU spec is a little bit, you know, behind. You know, there's been a lot of focus on the 5G new radio specs for licensed mode and license assisted mode and some of the other ways of going. I think when we get to the point where we get there, it's going to be, like you said, release 17. It might even delay, you know, with everything else that's going on in the 5G area and infrastructure building. One of the things I'd say is there's nothing that precludes that in the future. I think that by taking advantage of AY today and using the IEEE spec and the standards as developed, we're going to have a lot of learning, and we're going to even make that spec in the 3GPP spec better.
Absolutely, and you know, it is sort of increasingly a challenge, well, a challenge and opportunity to see how different technologies, different solutions can work together to make sure we get everybody connected. the way they need. And maybe Gino, you can start talking about that, because I understand you're using Terragraph already. So what is it you're doing with it?
That's correct, Monica. We got notice of Terragraph about maybe 4 years ago when Facebook originally announced the project along other projects related to connectivity, and we immediately joined the telecom infrastructure project just to get notices of what was going on. And we've been watching Terragraph for a while because the whole reason behind it is that with this technology we could be able to deploy gigabit style speeds and services in areas that, at least for us, fiber was either not possible due to infrastructure issues or too costly. We were able to engage Facebook last year during the Mobile World Congress so that we could do a trial here in Puerto Rico, specifically in Old San Juan. This is a very historic city, it's about 400 years old. And for that very same reason, we couldn't trench any fibers on the old streets, or the infrastructure to lay aerial fiber was pretty limited to non-existent. So that was the perfect case to deploy it. We reached out to them, proposed the project, and they agreed to help us deploy a pilot in Old San Juan, which we've been running since last October. We were able to deploy about 14 nodes in about a couple of weeks, pretty fast. And we just started signing up customers just after that. Starting on November 1st, we installed the first customer. And since then, we have a great experience with the product. It's been able to perform capacities that we expected. We're providing over 500 megabits of service, up to 1 gig. I think my connection is kind of breaking out or something. Sorry about that. But yeah, we've been pretty happy with it. We currently have about 15 trial customers on the network. And the network is composed of about 14 nodes, mesh nodes, the whole mesh, and it's been working pretty damn reliable. So we're very happy about it.
Absolutely. So what area do you cover with that mesh?
It's I would say like it's a kind of a 2 mile square area in the old San Juan city. Our plan is to expand it a little bit further and cover the whole old city. Which is not pretty big, but there's a lot of it's very dense area with a lot of residential and business mixed in. So and everyone, it's very I would say broadband starved, because there's no fiber in there, and the only transmission technology available there is pretty old copper lines for DSL. So you might imagine that those people are basically suffering on 5 to 10 meg services.
Well, it's actually pretty good, because, to talk about miles and 60 gigahertz together, that's already kind of an entirely new thing, because, but obviously mesh architecture allows you to do that. And before we get to Derek, let's talk a little bit about fiber, because every time you talk about fixed access, there's always the question comes out, but isn't fiber the way of the future? Why don't we just move and have more fiber? Are the two, how do the two relate to each other?
At least for us, they complement each other. We see fixed wireless, various technologies within a fixed wireless ecosystem, and fiber complementing each other pretty well. And now with upcoming 5G, that's going to expand more. There's some areas that technically fiber is too costly to deploy. There's no question about that. And then it's some other areas that you cannot deploy fiber because of the infrastructure does not allow it. So it's a mix that each technology complements each other, and we've been pretty successful with it.
Absolutely, and I think that's the key of the success is to be able to integrate the technologies rather than choosing one or the other, which I think was the problem. In the past, a lot of wireless ISPs would just for a lot of reasons they couldn't do otherwise. They would just focus on one technology only, and that makes the business case so much harder. If you mix different technologies, you're able to cover a wider footprint, and you can, it's really to your advantage from a cost point of view, because you can get a better business model, because you have multiple technologies that you can use for the same service.
That's right.
Cover a bigger area.
and also to expand a little bit on that, we are also evaluating how can we expand this technology in areas that already maybe has fiber, because if there's already fiber in an area, you as a competitor uh, kind of think about deploying another layer of fiber, because it's too costly, and then the amount of customers you will be able to grab will be minimum. But with this kind of technology, you can go and compete in those areas with a lower cost of deploying this service, and then compete with areas that already have fiber. So that's another plus for this technology.
Absolutely. So yeah, that's a huge plus. Derek, are you seeing the same thing?
Yeah, I think you hit it on the head when you said, it's about convergence and recognizing that all technologies have a place, and being able to find the right model to be able to use all those technologies. When we set up our military footprint, for those of you who've been to military bases, there's buildings, usually they're congregated together. And so by being able to bring fiber into one building and then use point-to-point radios to be able to get access to each of the building, that gigabit access to each building, it just makes a lot more sense instead of trying to run, if you got 10 or 5 or 10 or 15 buildings all in one little area, and then you got this vast openness around there where they're doing training and they don't want you to dig up the roads, and there's a mission going on. It makes sense to be able to provide that kind of use this point-to-point radios and use something like Terragraph to provide that connection. Today we have Terragraph. It's in the lab. We're waiting for the real one to come out. It's supposed to be here in the next quarter. Some OEMs that come out with some ones that we can use in venue or inside the military base footprint. But one of the things that we are using is we're still using some point-to-point radios in every frequency. I've got some CBRS band, typical CBRS band stuff. We've got 5 gigahertz, we've got 38, we've got 28, we've got a lot of different frequencies out there today, each providing different levels to be able to provide connectivity. So some are, smaller, maybe a 25 megabit link, and some of them are a lot larger. If I could make them all multi-gig links by using something like Terragraph in a very inexpensive way across all these buildings, I can now get more and more buildings connected without having to trench and do fiber to all of them. And one of the challenges in the military footprint is the individuals are moving from building to building all the time. They shut down buildings. They're going away to do their operations overseas or wherever they're at. And then, so that building's staying empty. And so by being able to take a low cost option like this, it ends up making it a lot more economical, because you can just move those radios and very easily to fit another building, and or you have the option of just leaving those radios up because you're not sinking that cost that makes it not efficient for you to be able to use. So convergence for us is the key. It's about finding the right technology, putting it together, and then making the solution so that you can get gigabit speeds everywhere you want them.
Absolutely. And sure, to clarify, how is the military staff in the military bases, how do they access the network? Do they need to have 60 gigahertz on their phones or devices?
Yeah, so it's a Wi-Fi, right? So throughout the building, there's Wi-Fi, and we actually have some locations where we did CBRS. So you're using the 60 gigahertz as backhaul back to the, where you do have that fiber in many locations, and then back out to the internet. So it's kind of the backhaul solution for each of the buildings. And then throughout the building, you're using either Wi-Fi or small cells to be able to, other types of LTE small cells, to be able to provide the last mile or that link to your phone or your PlayStation or whatever you're using.
Absolutely. So Mark, do you want to comment on, why we see why Derek and Gino picked 60 gigahertz. So from your point of view, why using that rather than your other millimeter wave frequency or E-band or anything else?
It's really the unprecedented amount of a couple things, right? It's this unprecedented amount of essentially free spectrum. And if you look at the various bands that are continue to be auctioned globally in the millimeter wave spectrum area, they're great bands, and they may serve a purpose, a good purpose for the people who are bidding on them. What we wanted to do was provide an ecosystem that was really able to use free spectrum so that anyone could use it without having to go buy licensed spectrum, number one. Number two, drive an ecosystem that would also lower the cost of deployment. So as opposed to, let's say a more conventional 3GPP type of gear, this is a little more along the lines of an IEEE Wi-Fi type of specification, where you'll see a lot of different players using Terragraph for fixed wireless access, as well as some other fixed wireless use cases that it's pretty well suited for with point-to-point and point-to-multipoint. So lower cost, unlicensed spectrum allows anyone to use it. Just on that point, we're also spending a significant amount of time and doing what we can when we meet operators globally and the band is not yet been regulated in their country or it's under consideration. So basically showing the benefits that anyone can deploy this. Multiple carriers could deploy it and serve broadband customers who just have a dearth of availability today. This was really the best way to go.
So why don't we go with the second poll to start looking about what are the alternatives to 60 gigahertz? Kendra, do you want to go with that?
Okay, launching the poll now. Let's see if it works. Okay, first question. What bands are in competition with 60 gigahertz for fixed wireless access? A, white spaces, B, sub 6 gigahertz, C, 5 gigahertz, D, licensed millimeter wave, or E, E-band?
And I guess we didn't put fiber as a possible answer, but I guess that's we talked a little bit about fiber, but let's talk about the different wireless options.
And 70 and 80 is there too.
Oh, right.
We've deployed some of those recently, and they're working really well too.
Yeah, and I guess again, it really depends on what is that you're trying to do, and in different environments, you have different solutions. That's always the challenge. And so, in all the questions, all the polls we have, there's no right or wrong questions. It's more of a trying to see what is that you think, and then we can go from there.
I noticed one of the things that you unless I missed this on the poll, you did have sub 6 gigahertz on the poll, which has been used pretty extensively. But I don't want to color anyone who's looking at how they're going to answer on the poll right now.
Okay, why don't we look at the results?
Okay, the results are in. Whoops. We have licensed millimeter wave came in at 36%. E-band received 30% of the vote. 5 gigahertz, 19%. Sub 6 gigahertz received 11%, and white spaces received 4%.
Well, I guess it's not really that surprising, the results, because there's so much talk about millimeter wave. So do you guys want to comment on that? Is that what you were expecting?
Yeah, that's what I was expecting. Licensed millimeter wave being deployed by the carriers for 5G has been talked about quite a bit. 5G broadband use by Verizon and the use by T-Mobile and AT&T is also very high in that band, in those millimeter wave bands. So it doesn't surprise me at all. I think the carriers are deploying those bands, and I think that's also helping us get better at how those bands are being used. So, as we look at that, the more we deploy these millimeter wave bands, the smarter we're getting. I shared with you guys earlier, one of the challenges we've had with some of the deployments we've done is trying to make sure that those radios are operating always at the peak of their capabilities. and it's very easy for them to get a little bit misaligned, and based on some of the software there, they end up erroring a lot of times on quality of service. So they'll go into some kind of degraded mode where you were probably getting a 5 gigabit link or a 10 gigabit link or 3 or 1, depending on your radio. And then they go into this mode where they might get misaligned or there's some kind of interference. And so they kind of readjust themselves and they don't take advantage of that full link that they can anymore. And so then if you're not monitoring that and watching that, so that you can tweak it to get it back up to use those higher speeds, it'll stay down at that lower speed because of the quality of service. And so one of the things that we're learning by deploying all these different types of radios from all these different vendors is there's different things that you need to watch from each radio so that you can make these tweaks to provide a better connection. And we recently found one that, one of these nuggets like that we were able to start pulling in from log files. And we noticed when it did drop down, how long it was dropping down, and then that we could, without affecting quality of service, make that adjustment and get that speed back up. And I think that to me is the key thing, whether you're talking any of these spectrums, is really there's a little bit of management required. And so you need to have a team and, your network systems primed to be able to look at these kind of new issues that come up. And so there's a little bit of work there that we're working in the standards along with Terragraph. And I think that's one of the key things that's coming out of the standards that we're doing with Facebook is we're recognizing that there's an operational requirement that we also need to focus on, and how to make it easier to operationally manage these networks so that you don't have to have, thousands of engineers watching this all day long. And that's, why I think the carriers have always typically been good at this, because they've had these really expensive network management systems. And so it's precluded others of getting involved. But by being able to create some standards, understand those KPIs, we're able to also solve some of the operational challenges that are inherent in some of these spectrums that we're moving into.
Yeah, and there are things like, using things like reflection and things like that, which are clearly not really that's not something you start from. So there's so much that we can learn, and the opportunity there, it's huge. But as you say, there is a lot of work, there's a lot of learning that we need to go in to do in the process. Now I was not paying attention, but we have a bunch of questions there. So if there is any question that you guys want to take, let me see.
There is a question, actually. There's a number of really great questions, and just to take a second to thank everyone who's putting these great questions in. One of the questions about the market size and that fiber is everywhere, and just quickly on that, you're absolutely right. And by the way, fiber and Terragraph it's a hybrid wireless network. So we depend upon fiber pops in order to get gigabit speeds that flow through the network. What Terragraph can really do is provide fiber adjacent to where it's already been deployed very quickly and inexpensively. And so there's a question also about the TAM, essentially the market size. And if you look around the globe today, half the planet has either very weak or no connection at all. And in a lot of countries, there's hundreds of millions of people with really no internet connection. Obviously, job one is connecting folks up. So anyone who's watching this webinar right now is not doing it over dial-up or a DSL connection, most likely, maybe VDSL too. But you need a healthy broadband connection to operate the way we have to all operate now from home, but just going forward, this is sort of the new norm. So there's two issues. One is connecting everyone. The second is connecting them with sufficient amount of speed, be able to use modern technology. And really, so we're seeing that the total market globally is fairly large. Why? Because until you get fiber there, it could take, in some cases, years to trench or run fiber in certain areas. And this is a solution that can go up really rapidly. And it's really one of the points: inexpensive and quick to deploy, provided the regulations allow its use, which is which is being unblocked in countries right now, is fine in North America, places in Latin America, in Asia, and so forth. Because it's new, regulators haven't had a lot of time to look at it and have been using some other regulations. Makes sense that it's really not available everywhere yet, but we think the market is fairly large for this, and that's really why we tried to contribute to it. We're not selling this ourselves at Facebook. We're just trying to contribute to areas where we think we could contribute and make a difference.
If I can talk with my analyst hat right now for a minute, when you look at the market size, you should really be looking at the market size of, so clearly you can address the people that do not have broadband, cool. But if you look at people that currently have a broadband connection, even a fast broadband connection, that is an addressable market, because what you do, as Mark was saying, it's a hybrid solution, it's fiber and wireless. So for instance, you might have a strand fiber on the street where you're living, but then you can use something like 60 gigahertz or wireless connection to your home. So you avoid the wiring, you avoid all sorts of costs associated with having fiber. So when you look at the market size, you have to be very careful in terms of, you can address some of the people that do have basically fiber connection pretty much to their home. So it's more than just saying how many people do not have broadband, if that's.
Yeah, and expanding on that, I would like to just, even though a market might have fiber, you can come in with this technology that is most way beyond cost of fiber, below cost of fiber, I might say, and then you can compete with other fiber providers. Just for an example, even though we are using pilot radios in our network deployment, that's a trial. I was just in a seminar with Cambium Networks, and they kind of released MSRP pricing on their equipment. For example, the what would you call it, an access points? They have a 270-degree coverage. The MSRP will be $999, and then the CPE, the CPN, the MSRP will be $199. So on the AP, you can load it with up to 16 customers. So that means that for about $300 to $350 overall cost, you can serve a area with gigabit speeds and compete with fiber. So you can go in and charge 45, 50 bucks, whereas the fiber is maybe charging 70 or 80 bucks, and just compete with them. So it's not a matter of the downside of technology versus fiber. Also is in terms of market demand and the pricing that you can offer and compete with other service providers in the area.
Absolutely, and then it's also faster, because even though you might need to have a technician to go and install the CPE, it's still faster than digging, even aside from the cost, right? Yeah,
most definitely. The deployment is going to be pretty fast in areas that there's no fiber, and also you can compete with the cable company, with their DOCSIS system. They're providing maybe up to 1 gig in some areas, lower speed in other areas, and you can come in and compete with this product in those areas. Even though you need to know that it's for urban areas, and might I add that even though this system now is 60 gig, if a manufacturer comes out with a dual system that has a 5 gig backup, that will be even more interesting, because then you can extend your radius of service a little bit more, and then continue to provide service in a rain event. So that you can extend more your services. So we're waiting on that manufacturer comes out with a 60 plus 5 radio, so we can do a bigger radius and networks.
Absolutely. There is a question here for Derek, I think, and then I will let you guys see what questions you want to address. So it's why not use point-to-multipoint radio for the military-based camps? Give more flexibility. Derek, you want to?
Yeah, I guess why not? I'm trying to understand it a little bit, but I mean, we do use point-to-point radios inside the military bases. I assume you mean when they're deployed. I guess, for me, when I started out in this business, I started out in the military, and we started using point-to-point radios to manage the battlefield, and back in 1992. And so we had this thing called Miles 2. So point-to-point radios has been being used by the military for a long time. Some of the new battle technologies in the military, and I know I'm getting off topic, but you know, they've been using them for a long time to be able to understand where soldiers and Marines are deployed in a battle scenario. So the key thing on the military base when we're dealing with these radios is making sure that we don't interfere with some of the stuff that they have. And so that's one of the advantages to the 60 gigahertz that we're talking about is really the bandwidth that you have available. It's a lot of bandwidth that's available to be able to be used in this environment that we find ourselves operating in. And so it's a great opportunity to try to pull down some of those radios that maybe we're using in 28 or other frequencies that may sit adjacent to some of the military operations. So we're excited about these radios coming into commercial deployment here, and hopefully in Q2 is what I'm being told by one of our suppliers, one of our vendors, and starting to slowly replace what we have in there with this improved connection. And then to the point that Gino is making, we're not planning on ripping out the old ones. That's another nice thing about networks is you find is you never pull down your old stuff. You kind of add to your other stuff, and then that way you have that kind of additional defense and depth. I mean, I've never, a good example of this, as we've deployed DAS networks for carriers inside venues, they never tell us to take down their old frequencies. When they start putting up new frequencies, you always just put up more and more. And that's another thing I think people sometimes think is that when you start putting up one, the other one's going to go away. And that just, that really doesn't happen very often at all. It's usually an additive solution because of, the different capabilities of every frequency. And, there's a need for more and more, and you've got devices that perhaps only support those other frequencies as you deploy. So you just keep adding to, and that's what we're doing. We're seeing growth, year over year. And, with this latest thing with, I'll just say all of us working from home, we're all learning a lot about making sure that we have extra capacity and the ability to adjust that capacity, very quickly. And I think something like a point-to-point radio, we're working on it with, some programs that are trying to make sure that there's connectivity in areas because of the quarantines, and being able to put up point-to-point radio very quickly, in a quarantined barracks, for example, is key. It's something that we need to be able to do. We're not going to be able to go figure out where to trench and how to do all of that really quick, but the speed of being able to put up that radio is key also for these installations. So to go back to your question, I think, military base camps and using it, that's the key thing is for them, they've been doing it for a long time. It's flexible. And I think we're starting to take advantage of that flexibility in, the civilian sector or the commercial sector inside the military like we do.
Absolutely. So there is another question about the long distance backhaul, if it's a problem for remote areas. And so Mark, I'd like to ask you, so this is a question for you, but I'd like to sort of broaden it a little bit and talk about the ability of something like Terragraph to bridge the digital divide. So what is your scenario? Because with Derek and Gino, we've been talking more about places where there is some connectivity, but as you go out in a place where there is no broadband connectivity, is Terragraph going to help there? And what kind of backhaul would you be using there?
So if you're looking at rural communities, or let's say less highly low population density areas, the system, because it's relatively inexpensive and unlicensed, can be deployed in areas where you have some type of access to a POP or some type of access to broadband through either a fiber POP, as I mentioned, or some type of E-band or other wireless backhaul that's going to a fiber POP. And then within the confined area, let's say there's 500 homes, few hundred homes, something like that, having a small distribution network that's relatively thrifty, and you heard Gino talk about the cost before. With respect to using Terragraph itself to do long-range backhaul. As I mentioned, there's some techniques and some, let's say, specific radio products that are being developed to address that will go slightly longer and maybe not require, because they're kind of almost operating like point-to-point exclusively, the same type of phased array that we would use for auto alignment, for point-to-multipoint operation, beam refinement, and so forth. So that's certainly an option as another type of SKU and another type of radio product. But the real advantage is when you're talking about the digital divide, it's obviously not just in rural areas, but to be frank, there's a kind of a digital divide in a lot of cities as well, and a lot of urban areas as well. And it may, you know, you look at a coverage map or let's say a study's been done to determine what the penetration of broadband is in an area. A lot of times, even when it looks pretty healthy, there's huge pockets where it's just not economically advantageous for the operator, maybe to pour a lot of capital into certain areas. And that's where we think we could play a big role as well, and as well as in the urban digital divide.
Yeah, and oftentimes that those areas, not both in rural and urban or suburban, where you might have on paper connectivity, but you really don't, so you have some dead spots, are actually underestimated pretty much everywhere. Because whenever you look at a map, everything looks pretty good, but then when you go in reality, it's not necessarily the same.
And while it is you know, there's a couple components to it. We haven't really talked much about the mesh component of it, which is really the way that you spread out limited amount of fiber pops in a city using the mesh, which is adaptable, which is why that's part of the system. The other component of Terragraph is really the drop, or just going from where you have access to where you don't have access. And that's where it also fits, where you have aerial fiber potential. We looked at fiber working together in concert with wireless, because it's you'll have a high-speed broadband base, essentially fiber speed for the purposes of the customer who's getting it, with a 15-minute install going between the pole and the customer's unit. And with point-to-multipoint, you can go 15 units on the side of a building from the same point on the street. And so there's a lot of areas where you have high-density MDUs where we believe it can help solve the problems that are in there as well.
Yeah, absolutely. And actually, if I can ask both Derek and Gino a little bit about sort of the performance on the mesh side, because 60 gigahertz doesn't have necessarily from the past the best reputation for being usable, but mesh has a similar problems. Because when you talk about mesh, so people say, "Oh, but how does it work if you don't have enough density? What happens to the latency? What happens to capacity?" So can you comment on that? And especially because now with the ability to also use MIMO beamforming, that also seems to be helping together with mesh to get a better performance. So what is it you're seeing in terms of the performance and in terms of really physically setting up the mesh?
Well, without getting into much details because we're kind of short on time, but the Terragraph mesh is kind of self configured. You just install the radio, register it to the cloud controller. It will automatically pair with the network. So it's pretty close to plug and play. In terms of performance, what we're seeing is the average speeds the user are getting. It's about 600 to 800 megs. We have tested peaks of over 1 gig, obviously using 10 gig interfaces, so about 1.5 gigabits per second. And that's using AD radios, which are the ones that we use when you're using AD-based pilot radios. With AY, we will possibly be seeing double that. So in latency-wise, we're seeing within the mesh about an average of 2 to 5 milliseconds of latency within the mesh. So the performance is pretty good.
Absolutely. So I would like to get Derek to comment on that, but before we do that, could we go with the third poll, and then we'll have Derek comment on this. So Kendra first.
Okay, the third poll. Question number 1. This is a two-parter. What is the biggest advantage of 60 gigahertz in fixed wireless access? We have unlicensed band, free spectrum, frequency reuse, limited interference, low-cost equipment, or small footprint of equipment. And then question number 2 is, what is the biggest challenge for 60 gigahertz in fixed wireless access? We have line of sight requirements, short range, unlicensed band not being a protected investment, or a weak business case.
Okay. So Derek,
Great questions.
comment on the performance first, and then we can comment on the results.
Yeah, I mean, thanks, Monica. I would just say that, you know, one of the things that you're doing when you're building any network is you're looking at the network as a whole, and you know, you upgrade your mesh network, and then you need to, oh, what's my backhaul doing? And so you're constantly looking at all of it together. You know, so in the example we're given, where Gino was talking about, you know, if we use a mesh network, we're seeing in some of our networks, we're seeing 7, 8 gigabit speeds across those radios. But then you're using, you know, Wi-Fi throughout the building and to provide the connection to each room, right? And so, and then from there, you're going back to another fiber network, and you maybe only have a 2 gig backhaul, right? And so you're always doing this link budgets where you're trying to understand what you need in each, all the way through. So it really is, for me, it's more about doing that work of designing the network. And as you're doing that work and designing the network, you're thinking through how you set up that mesh to be able to provide the lowest latency. And in some cases, you know, if you got 10 buildings, you know, you might do, you know, 1 radio on every 2 buildings, and then 2 radios on the other 3, the other fill in to try to provide that. And it's really about understanding and building that out. And I know that there's a little bit of a science to it, but it's also just doing that work to understand that. And then, as Gino said, providing perhaps sublinks, you know, in 5 gigahertz or some other frequencies for that degraded mode that you always need to plan for. So for us, you know, we're trying to provide a 100 meg service in a lot of locations. 50 megs our standard to every room using wireless technology, limited fiber, and we're able to do it. So I think that with 60 gigahertz and you know, this big swath of frequency we'll be able to get, we're going to be able to start getting that gigabit speed per room, and that's really what we're aiming for. And that requires, you know, an upgrade across switches and everything else as well that you start doing, you know, as you start connecting it all in. So there's other costs you have to just bring in, and it's really about putting it all together, all those technologies together. So I don't know if that answered the question. Hopefully it did, but very excited about it.
Absolutely. Let's get to the results of the third poll, and then we can have everybody have some closing remarks.
Okay, our results are in for the first question about the biggest advantage to 60 gigahertz. Unlicensed band, AKA free spectrum, came in at 53%, frequency reuse and limited interference, 36%, low-cost equipment, 11%, and small footprint received 0%. And for question number 2, what is the biggest challenge for 60 gigahertz in fixed wireless access? Short range came in at 43%, and line of sight requirements received 40%. Unprotected investment received 11%, and weak business case received 6%.
So very quickly, we're at the top of the hour. Maybe we can squeeze in final comments. Mark, go first. You want to go first?
I'll go first. First, thanks everyone for contributing, participating. Derek, Gino, Monica, thanks for helping put all this together. And thanks everyone for listening. There are some of the most incredible questions that we're seeing here. And I don't know, we can get to answer those online later, just to address them, because there's some great questions there. And that's it. Thanks so much.
Derek and Gino, do you want to have final comments on the results?
Sure, I'll go. Thanks, everyone. I'll echo what Mark said, and stay safe. And hopefully, like Mark said, we'll send you some answers to some of your questions. And feel free to reach out if you have any other questions that you would like us to answer. Thank you.
Yeah, thank you very much for the invitation. It's been an awesome experience and great panelists. I would like to add that, you know, the 60 gig Terragraph for fixed wireless is another tool within your tool set So all the operators might, use it as they see fit, by complementing it with other technologies. The convergence part that Derek talked about is pretty important. So I'm very available to answer any questions you guys have. I might try to catch up on some of the questions that were sent on the question app. So yeah, just keep in touch, and glad to be here. Thank you very much, and stay safe and wash your hands.
Absolutely. Well, thank you so much for participating. And we do have a lot of questions, so we'll try to answer them offline. And as I said, if you have any more, send them in and we'll do our best. And the webinar will be available offline anyway. So you can listen or get other people to listen to. Kendra, back to you.
Okay, great. Thanks, Monica. That will conclude the webinar for today. Thanks again to our panelists for a great discussion and for the audience for a great set of questions. And also thank you to us on Twitter. That was fun also. This webinar will be available on demand on SenzaFili.com, and we will email instructions to all the registrants on how to access that shortly. And thanks again to our sponsor of today's webinar, Facebook. We have 2 upcoming webinars. One is next week, March 26th at 11 a.m. Eastern, Beyond Licensed and Unlicensed Spectrum. And then we have another webinar, April 7th, also at 11 a.m. Eastern, and that's Do Emerging Markets Need 5G? And the sign-up forms are available on SenzaFili.com. So thanks again, and we look forward to seeing you at future events.